Oh man, I hate this. So here I have a 516 BSW tap and they want me to drill a 6.5mm hole. Yeah, you know what, that's true some of the time, but it's not true all of the time. And in fact, most of the time, if you drill a 6.5mm hole with this tap, you're just going to blunt your tap. There's a few of these old wives' tales that seems to have creeped through the industrial age into modern home workshops. Another cool one is you need to go half a turn and then a quarter turn back to break the thread. Now, this is true for a 4-flute tap, but a lot of the modern taps are either 3 or 2 flutes, and then that doesn't work anymore. In fact, all you end up doing is just blunting your taps. In this video, I'm going to have a look at how to use these little guys more effectively, and more effectively in weird positions and hard to get places. I'm going to have a look at how these guys fail and how to improve the life of your taps. I'm also going to have a look at single point thread cutting on the home workshop lathe. And then just for fun, I'm going to show you how to make a very cheap and effective home chaser with stuff lying around. And we'll use that for a weird thread, something like a M16 by 1mm thread, something very odd and interesting. But before we get there, let's have a look at how to use these little guys properly.
By far, the worst place to tap is at the bottom of the vehicle on a plastic little insert. The chance of cross-threading is really, really bad. One way to get around this is to use a tapping guide. And this works equally well with both dies or taps. If you put the tapping guide flat against the hole that you've drilled, then that tap will go in 100% straight each time, like so.
So let's get back to the Whitworth tap I showed at the beginning of the video. The 6.5mm printed on the side of the tap is typical of the published tables, and this is what is generally specified in industry, something around 80% of thread height. These published tables are for production machines, where the automatic reverse needs to cope with the overload at the bottom of the hole. For the home workshop, this is very seldom needed, and we can save our taps by not drilling according to these tables. But how much are we compromising on strength? Well, if you drill a hole that is equivalent to the smallest diameter of the thread, in other words 100% thread height, you'll likely break the tap, simply because most materials have a certain amount of deformation or extrusion causing the tap to jam and break. From a strength point of view, a thread fastener is 4 times more likely to fail in tension than due to bearing or shear failure of the threads, depending on the material application and thread engagement length. For that Whitworth example, if you use a tapping drill of 6.7mm instead of the 6.5, you only lose a small percentage of the bearing strength without compromising on the tensile strength of the joint, and the tap will last much longer. This is particularly helpful with materials like stainless, which are notorious for extruding at the root and breaking taps. Right at the end of the video, I'll put up a few tables with drill sizes and which materials these are suited to. Of course, the design of fasteners is a little bit more involved, but in terms of thread cutting, this will do.
Alright, let's make some curly whirlies on the lathe. I'm going to do an M16 by 1mm thread. Now that's a special machine thread, so it's not a common thread, and I'm doing something a little bit different for you guys. M16 is just M is the metric, 16mm is the major diameter, and 1 is the 1mm pitch of the screw thread I'm going to cut. Now, a lot of people forget about the thread shortening when they cut thread, and if you use a die, you typically blunt your dies if you don't do the thread shortening. Thread shortening is just the outside diameter minus the sort of top peak of the thread, and you need to do that before you start cutting your thread. Another trick is whenever you have your thread termination, so in other words, if there's a step in the bar, so you cut your thread and there's a step, and then you have your sort of the rest of the shaft over there, it's always a good idea to do a slight undercut. And the reason is when you use your tip tool, and it comes from the right to the left in this case, it has a better transition from the screw thread into that little groove, and then you can pull your point out. I typically do not use a parting tool over here. I use a round nose tool. Now there's two reasons for that. The first reason is it's much better for fatigue strength. So this is a much stronger end of shaft. But also, if your tip tool comes from the right to the left, it has a more uniform breaking into that slot. So you're not cutting and breaking the end off like you would do if you would cut a square groove. For the home workshop, I always recommend cutting screw thread on the taper slide, and the reason is very, very simple. Our machines don't have large motors. The amount of power that you need to cut screw thread is quite large. So what you want to do is you want to decrease your cutting surface area as best as possible. And let's be honest, if you cut on both surfaces, if you plunge into the workpiece and you grind along the workpiece, you're making a horrible wedge. And also, how do you grind it? You can't shape that tip to grind or to machine efficiency. It just won't work because your rake is always going to be in the wrong direction. If it cuts on this surface, your rake for the other side will be wrong, and also your height will always be incorrect. If, on the other hand, you only cut in the direction that you're moving on the one surface of your pointed 60-degree thread cutting tool, then you can cut your rake away. It's always perfect, and the height is exactly what you're looking for. That's all fair and well, but how do you set this up? Because on my machine, for example, this angled gauge that the machine came with for the taper slide doesn't go to 60 degrees, so I actually can't use it for thread cutting. All right, what I can do is I can set it on 30 degrees, and I can bring my tip tool up to the chuck, and I can set up the tip tool relative to the chuck. So I know that the cutting surface is perfectly set up relative to the workpiece that I want to cut. All right, so that's half of the job done. But how do I get my 60 degree that I want to plunge into the workpiece so that I don't have to worry about grinding both surfaces of my tip? Here's a little hack that you can do in your workshop, and it works fantastic for these lathes. If you set your cross slide more or less at 180 degrees, so it's parallel in this direction, you bit a DTR on your tool post and you drag it across a faceplate or the backing plate of your chuck. When that's zero when your DTR is zero from one side to the other, you make a mark over there that lines up with the zero of this angle gauge, and now you've changed your top taper slider to any position because you have more than 45 degrees in both directions in this plane and in that plane. Now setting up any screw thread is actually much easier, because what you do is you set it at 30 degrees in the front. You get your cutting edge to be flat against a reference surface, so it'll be the key chuck jaws or the back of the chuck or the faceplate or whatever. It doesn't matter as long as it's sort of flat against that. And then when you flip it back, you use exactly the same increment, 30 degrees on this plane. Now you don't need to minus stuff and do all sorts of funny calculations. So now this is set up perfectly to cut for the taper slide. Of course, there are other ways of doing this. You can use one of these very fancy thread cutting gauges, and you can make sure that the cutting surface is correct to the one side. Or you can use a large bolt. It'll be exactly the same. That'll also work. But by far the most accurate way of doing this is by using the taper slide and using the angle increments like I set it up on my lathe. It works fantastic. It's well worth doing that little mark on your lathe. I've used this a number of times. But look, enough talk. Let's actually cut some screw thread and let's see how this works. All right, let's finally get to cutting some thread on the lathe. One of the things when you use the taper slide that actually works really, really well is because you're not feeding with your cross slide and using the same dial every time, you're not losing your position. But let me show you what I mean by that. Let's just take the taper slide. We're going to set it on 0 and we're taking all the backlash, so we're putting it forward. Let's just touch the workpiece. Now what we do is we zero the cross slide like so, and if we put it back on 0, we can feed the taper slide and then bring this back every time we go backwards. But let's take a cut. I've set my gears and I've put a link to another video I did for how to set the gears in the lathe, so you can have a look at that. But the gears are set for a 1mm pitch. Put a little bit of thread cutting juices on. We're going to engage the half nut and then we're going to engage the gear. And I'm doing quite a big cut because this is mild steel. So this is the first cut. So this is a 1mm pitch that we're doing. And then as I get to that groove, I'll pull away and I'll stop the machine. Now at this point, there's two different ways to go backwards. You can either reverse your machine and then we can go backwards like that. Or if you're lucky enough to have one of those lead screw dials, that also works. But I typically don't use it for thread cutting like this. That's only for the much longer threads. Now look at this. Now we can go back to 0 and we're still in the same advanced position on the taper slide. So we don't need to do any calculations. By the way, for a taper slide, your depth of cut isn't the same as your cross slide because there's an angle involved. And in the tables that I'm going to put right at the end of the video, there's a last section, or the last column will tell you how much to plunge with the taper slide. And for this specific type of screw thread, it's 0.7. So I would typically do 3 cuts on a 1mm pitch like this for a 0.7. So it's one sort of deep cut, the second intermediate cut, and then the final one would be a nice finishing cut. So we're going to flip the lathe going backwards. And now we go back to 0 on the cross slide. And the final cut for this thread is 0.7. And then this is the final cut of this one. And look at that. That looks pretty cool. So I promised you guys at the beginning of the video that I would show you how to make home chasers with stuff lying around the home workshop. Now, just for those that don't know, the difference between a chaser and normal thread cutting on the lathe is a chaser has multiple points, where the normal way of cutting on a home workshop lathe is a single tip point like this. The advantage of using a chaser is it's typically an off-the-shelf item, so the thread profile and pitch is perfect. There's no grinding or anything that needs to be done. The problem is these things are incredibly expensive and not really viable for the home workshop, but there is a way around this. You can actually make your own chasers from taps, and as long as the pitch and the thread form is the same, it is just as good as a commercial chaser. The only drawback is taps are relatively flexible, so they can't stick out too much. You do need to make your own little holder like this, and you can either clamp it like I've done in this case, and then this goes onto your sort of standard tool post, or what you can do is you can braze it into a holder if you need more of an overhang, and then just machine the sort of the excess away to get into those hard to get places. But all in all, chasing using a tap works really, really well. And the process is identical to normal thread cutting. You just set your pitch on your gears the same as you would a single point thread cutting tool, and you chase the thread. One of the major advantages of doing this is look at the difference in size. So this is a single tip tool, and getting it in there becomes very, very difficult. But a chaser made out of a tap, you can get in there to cut your thread. And that's exactly what I did with this little example that I've been doing. So this is an M16 by 1mm pitch, and an M6 tap is a 1mm pitch with the same thread form. Perfect. Great. That's what I used. Now, of course, these two methods are interchangeable. So you can chase either an external thread, or you can use a single tip tool, which I showed you previously in the video, or you can use a smaller single tip tool for internal thread, or you can use a chaser and vice versa. So this is the thread that I cut previously. It's an M16 by 1, very, very fine thread, and this was done using the chaser. And I think that will do very nicely, Luca. I hope you guys have enjoyed this video. Slightly different way of doing things. I hope you give this a bash, and let me know of your tricks for making threads in the lathe. Drop me a comment. Let everyone learn. Let's share with the other guys. Show your different ideas of doing stuff. And what I'll do right at the end is I'll post those workshop charts for you, and you're more than welcome to print them out and stick them up on your wall. Thanks for watching, guys.